Hello students, good morning. Welcome to the chemistry online classes. So in our today's IIT chemistry class, we are going to solve some of the problems on the basis of the electrode potential concept, that is regarding your Nernst equation, right? So in our previous class, we have already learned what is meant by the Nernst equation and what are the uses or what we can find from the Nernst equation. All those already we have learned in the previous class, right? Now coming to the Nernst equation, simply I can say that a Nernst equation is nothing but an equation which gives the relationship between the electrode potential at normal conditions and the electrode potential at the standard condition, right? That equation we call it to be as a Nernst equation, and the equation is can be written as, that is your E cell equals to E naught minus 0.059 by n log the concentration of product by the concentration of reactant, right? So this formula, once you can go through the last class, there we have the formula, this one, right? So on the basis of that formula, we are going to have some problems. We are going to solve some of the model problems which have been asked very frequently in the previous examination, right? Now let us see the first problem here. See, in the first problem, it is given here the voltage of the cell whose half cells are given below is, right? Here we have the one cell and they are given the half cell reactions here. What is the half cell reaction here? One half cell reaction is Mg plus 2 plus 2 electrons. It is giving the Mg, right? And for this electrode, the potential is minus 2.37 volts, right? And we have the one more electrode, that is U plus 2 plus 2 electrons. It gives the copper. For this electrode, it is plus 0.34 volt. Okay, so this is what the equation, right? Now coming to the case here, see from this, what is the solution we are going to use here? We are going to use a solution, that is E cell equals to E cathode minus E anode, right? This is what the equation. From the Nernst equation, we know that the total electrode potential is equals to the electrode potential of cathode minus electrode potential of anode. Is it clear, this one here? Now how you are going to find this one, whether it is an cathode and which one is the anode here? See, as we know that at anode always the oxidation reaction takes place, right? At anode always the oxidation reaction will takes place, and at cathode always the reduction reaction will takes place. Okay, at cathode always it is reduction, at anode it is always the oxidation. So on the basis of which one is going oxidation and which one is going reduction, we are going to select the reactants here, right? So actually here is a small mistake here. See, that is Mg plus 2. As we know that oxidation means what here? Loss of electrons, but in both the cases it is going to gain the electron, right? So actually here the 2 Mg plus 2, right? It should be in this case, what we get here? Mg, that is Mg plus 2 plus 2 electron. Actually this question is Mg gives Mg plus 2 plus 2 electron, that is loss of electron. That means it is the anode, right? Oxidation, loss of electron is nothing but oxidation. Oxidation will take place at the anode. And what is the potential given here? That is minus 2.37, and at cathode it is 0.34, right? So from this calculation we get the answer to be as a 2.71 watts. That is the potential of an electrode. Is it clear here? That is the answer for this one. That is the option 4, right? 2.71 volts. Is it clear, this one? What a point here. Now similarly we have the one more problem here. Let us check the next one. The EMF of the cell in which one of the electrode is standard hydrogen electrode is 1.2 volt. The potential of the other electrode is. Now what is the question is asking here? We are going to have the one cell. In that cell, one electrode we are going to use it to as standard hydrogen electrode, and the other electrode we are going to use, and here is given the total potential of a cell 1.2 volts. So what is asking me to find here? To find the potential of the other electrode, right? So as we know that, as we have already covered the standard hydrogen electrode concept, here standard hydrogen electrode is nothing but it is also called as a reference electrode. Why we call it as reference electrode here? Because this electrode is used to find the potential of the other electrode, and the potential of the standard hydrogen electrode it always taken to be as 0. Is it clear here? That is the standard value, that is 0. Now let us check how to find here. So the previous same equation what we have done, that is total electrode potential of a cell is equals to electrode potential of a cathode minus electrode potential of a anode. Is it clear here? So in this case, the one electrode, that is cathode, I am going to take as standard hydrogen electrode. And as we know that the potential of standard hydrogen electrode is always taken to be as 0 because it is a reference electrode, and the total electrode potential of a cell is given to be in the question is 1.2 volt. Okay, so from this relation what you get here, that is E anode equals to minus 1.2 volt, that is minus 1.2 volt. That is your first option. Is it clear here? What is here? This is how we are going to use this relation, that is E cell equals to E cathode minus E anode. This relation is very important. Number of questions have been asked. Okay, that is total potential is equals to potential of a cathode minus potential of a anode. Is it done there? Now let's check the one more problem here. This is the most important model here. The potential of the copper electrode, that is Cu/Cu plus 2 aqueous, it is given to be as 0.1 molar. Okay, so it is given to be as 0.1 molar is if electrode means here potential E naught of Cu plus 2/Cu is 0.34 volt. Is it clear here? Here he has given the one electrode reaction, and one electrode reaction he has given, and what the reaction here is, that is Cu gives Cu plus 2 plus 2 electrons, right? It is giving us Cu plus 2. So let's write the reaction here. So write the reaction. From this question we can write the reaction to be as, that is Cu plus 2 plus 2 electrons, it gives the Cu, right? So from this reaction, from this question I can write the reaction to be as copper plus 2 accepts 2 electrons, nothing but it undergoes the reduction, gain of electron to form the copper, right? Now let us see the question. Is it clear? This one he has given the concentration of copper, that is 0.1, and also he has given the E naught value, that is potential of copper electrode, that is 0.34 volt. Now from the Nernst equation we know that is E equals to E naught minus 0.059 by n log of concentration of product by the concentration of the reactant, right? So this is the Nernst equation at the standard condition, right? Nernst equation at the standard condition. Now let us check the form. So in the question is asking you to find the value of E. So E naught is already given, that is 0.34 volt, that is 0.059 by n. What is n value here? N is nothing but the number of electrons involved in the reaction. Okay, so in this reaction how many electrons are involved here? 2 reactions, that means 2 electrons, that is 2, n value is 2, log of concentration of product. So from this one, what the product here is? Copper, right? Copper by concentration of reactant. What the reactant we have here? Copper ion, Cu plus 2. And as we know that from the Nernst equation concept, that is the electrode potential of the metal electrode, that is copper, is always taken to be as a 1, right? The concentration is always taken to be as a 1 for the metal electrodes, therefore I am taking to be as 1. And the copper ion concentration, as the square brackets nothing but they are the concentration, right? Therefore the concentration of copper ion is given to be as 0.1 molar, that is I am substituting as 0.1 molar, and the log of 1 by 0.1 value is nothing but 1. Okay, so when you divide the 0.059 by 2, we get the value to be as 0.0295. Is it clear this one? So on the simplification we are getting the value to be as E equals to 0.3105 volt, right? That is the answer for this problem. Is it clear here? So far we have learned the 3 questions, and all these 3 questions are very important model, right? It might have took some time here to explain all this because these are very important. Few more are there problems, which we are going to learn in the next class. Fine. So if any doubts, you can directly WhatsApp to me. I'll answer the simplification to that question, right? Thank you.